Hello students, good morning. My name is Dr. Mallikarjun, working in Institute of Aeronautical Engineering, in the Department of Information Technology. In this series of video lectures of operating systems, today we will going to discuss about the process synchronization, or normally called synchronization, is the way by which process that share the same memory space are managed in the operating system. In the same memory space, there are more than one process need to share the resource. That time happening the synchronization. So, it helps maintain the consistency of data by using variables or hardware. So that we have to manage the hardware and software. Only one process can make changes to shared memory at a time. There are various solutions for the same, such as to control that process synchronization. That is Semaphores, Mutex logs, synchronization of the hardware. So, while process synchronization happens, that we have to make the solution for that synchronization. To make that solution for that synchronization, we used either semaphore or mutual exclusion or synchronization of the hardware. Let me check that process synchronization is used in a computer system that ensure that multiple processes or threads can run concurrently without interfering with each other. So, there are concurrently running then more than one process. This may be n number of processes concurrently running the same resource without interfering each other. So, the main objective of process synchronization is to ensure that multiple processes access shared resources without interfering with each other, and to prevent the possibility of inconsistent data due to concurrent access. To achieve this, various synchronization techniques such as semaphores, monitors, critical sections are used. So, in multi-process system, synchronization is necessary to ensure data consistency and integrity and to avoid the risk of deadlocks and other synchronization problems. Process synchronization is an important aspect of modern operating system, and it plays a crucial role in ensuring the correct, efficient functioning of multi-process system. On the basis of synchronization, categorized as one of the following two types: independent process and cooperating process. It may happen in synchronization either independent process or cooperating process. So, independent process, the execution of one process does not affect the execution of other processes. So, that is called independent of the process. Cooperating process, a process that can affect or be affected by the other process executing in the system. So, P1 and P2 not affect any other process. So, it may be called as independent. So, cooperating process means a process that can affect or be affected by the other process to each other. It comes under cooperating. So, P1 is affect P2, P2 it affect P1. What we said that P1 and P2 are cooperating. If not effect on other process, these two are individual. We can call it as P1 is different, P2 is different. We call as those two processes are independent process. Next, process synchronization is the coordination of execution of multiple process in a multi-process system to ensure that they access shared resources in a controlled and predictable manner. It aims to resolve the problem of race condition and other synchronization issues in a concurrent system. In the concurrency of the system, So P1 as count it should be 5 and P2 has decremented by 1. It makes effect on count variable. So count variable, it may be incremented, count is equal to count plus 1. It may be decremented, count is equal to count minus 1. So the steps has to load R1, count value, incremented by 1, store count value. Decrement means load R2, count, decrement, and store count value. So predictable manner, it means that synchronization P1 is effect on other process P2. It depend upon the count variable. Count is incremented by 1 in the cooperating process. This is happening in the cooperating process. This is the cooperative procedure. So this comes under the process synchronization. Let me see that process synchronization in multi-process system happening as either independent or cooperative. See, either in this figure, with these two P1 and P2 comes to each other, it is cooperating fashion. Process synchronization is important aspect in modern operating system, especially in multi-process system. This may depend upon independent and cooperating. These are two important. Here, P1 and P2 not affect on count variable. It's not affect on count variable. So these two processes are independent process. P1 effect on count variable, P2 effect on the count variable. So these two are independent. These two are dependent, means that it is cooperating process. Let me see that in the lack of synchronization in inter-process communication environment. So process synchronization always in the environment of the inter-process communication environment. It leads the following problems in the process synchronization. One is inconsistency, loss of data, deadlock. Inconsistency, when two or more processes access shared data at the same time without proper synchronization. This can lead to conflicting changes where one process update is overwritten by another process. So causing the data become unreliable and incorrect. This comes under inconsistency. So loss of data occurs when multiple processes try to write or modify the same shared resource without coordination. In one process overwrites the data before another process finishes. Important information can be lost. Leading this is to incomplete or corrupted data. This comes under the loss of data. Let me discuss deadlock. In the lack of synchronization leads to deadlock, which means that two or more processes get stuck, each waiting for the other or to release a resource because none of the process can continue. The system becomes unresponsive and none of the process can complete their task. This means that the process going to be deadlock. So in this process synchronization, the process it may be executed in the following any one of these conditions, either inconsistency, either loss of data, or it may be a deadlock. So in an operating system is a software that manages all applications on a device and basically helps in smooth functioning of our computer. Because of this reason, the operating system has to perform many tasks and sometimes simultaneously the processes are executing. This is not usually the problem unless this simultaneously occurring process use a common resource. That synchronization comes to a more process actually comparing the resources and executing the resources in the synchronization. Let me give an example for this. Either bank application, let me take user 1 and user 2. There is an account in the bank. That is current balance, let me take Y. Then account A, and process 1 deduct that same account and process 2 check the balance at the same account. This bank that stores the account balance each customer in the same database. This example of that process synchronization comes under initially have X rupees in your account. So initially has X rupees in the account. The rupees consist of X rupees in the account. Then now you take out some amount of money from your bank account, and at the same time someone tries to look at the amount of money stored in your account. As you taking out some money from your account after the transaction, the total balance left will be lower than X. Once you deduct some amount in the money, then total balance X is equal to X minus some money. So transaction takes time, and hence the person redads and your account balance, which leads to inconsistency of the data. In some way, we could make sure that only one process occurs at time. We could ensure the consistent data so that we make that consistency could not maintain from in the account balance. Means that some data it may be corrupted before the process 1 should be executing, then process 2 can be completed. Either it may be read or it may be write transaction performing concurrently, so that your balance can be get exact amount. So your balance cannot get the exact amount means that there is a problem in the transaction, means the transaction could not complete successfully, so that the synchronization can be handled. Let us take a look at why exactly we need process synchronization. If process 1 is trying to read the data present in a memory location, while other process 2 is trying to change the data present at the same location, there is a high chance the data is read by the process 1 will incorrect. This is the example of the process synchronization happening in the shared memory. See, process 1 read the transaction, process 2 write the transaction. In between that, process 3 is read the transaction. So, process 1 read the transaction, process 2 comes to write the transaction. In between that shared memory, process 3 to read the transaction. It may be the correct, it may be exactly, you can read the data correctly. So, that transaction executed successfully. If not the correct means, the transaction cannot executed successfully. So that it can solve the synchronization. The problem should be occurring in the synchronization. Let me see the in the critical section. The process synchronization is going to be the critical section. We already discussed this problem of the critical section. In the critical section, there is the criteria for 3 sections: entry section, critical section, exit section, and remainder section. Entry section, the process requests permission to enter the critical section. In the synchronization tools, Mutex, Semaphore are used to control access that should be there in the entry section. Critical section is the actual code where shared resources are accessed or modified that should be there in the critical section. The process release the lack or semaphore allowing other process to enter into the critical section. This is to be there in the exit section. The rest of the program does not involve the shared resources or access that is going to be there in the remainder section. Coming to the race condition. So we can solve this synchronization by using critical section, and also that critical section can be solved by using that race condition. In the race condition, that should be happening in the independent process and cooperative process. When more than one process is either running the same code or modifying the same memory or any shared data, there is a risk that result of value of the shared data may be incorrect because all process try to access and modify this shared resource. Thus, all process race say that may result is correct. The condition is called the race condition. Since many process use the same data, the result of the process may depend on the order of their execution. So that this race condition, this mostly situation that can arise within the critical section. In the critical section, a race condition occurs when the end result of multiple threads execution varies depending on the sequence in which threads are executed. To avoid this synchronization, to avoid this race condition, there is a simple solution. By treating the critical section as section that can be accessed by only a single process at a time. This kind of section is called atomic section. To solve this type of critical section and race condition, then you use that variable as a semaphore. Yes, a semaphore is a protected integer variable that allows any one of the process to enter into the critical section. So to avoid that synchronization problem, either semaphore means that by using mutex also is one of the thing as a function, mutual exclusion, and then mutual exclusion, progress, bounded waiting. These are the conditions to be there in the critical section. To avoid that is any one of the process to allow them into the critical section and came out of the critical section to solve this synchronization. Either Peterson solution, that also one of the solution to overcome the critical section problem. So either thing you have to apply to solve this classical process of synchronization. There is a various classical problems of synchronization, either bounded buffer problem, reader-writer problem, producer-consumer problem, barbershop problem. So all these problems, solution will be either semaphore or mutual exclusion, either monitor. These are the solution to solve this type of classical problems of synchronization. Consider a system consisting of n number of process, either it may be P0, P1, P2, and so on, n number of process. Each process has a segment of code called critical section, in which process may be changing common variables, updating a table, writing a file, and so on. When process is executing in the critical section, no process is allowed to execute in its section. So, no two processes should execute in critical section at the same time. The critical section problem is to design a protocol that the process can use to cooperate. So, that structure of that process can be solved with critical section. They use a Peterson solution. So, Peterson's solution gives the two variables I and j. Either I is there in the process, it should be waiting section, should be their process is to be executed. J should be is in waiting section, either I process is going to be executed. That's why flag I is equal to true, then turn the chance to j. Well, flag j is and turn j is there, then flag I is in the critical section. Then you can make flag I to false, then make them to other process to be in the remainder section. Like this is a loop, either it's a do while loop. The process can be either executing to not to be depend on other process. Two process made to be independent. So we should not want cooperating process. We make them two process independently. Then this is a hardware solution of the critical section with the synchronization. So either Boolean test and set method. A Boolean and gives the target variable. The target have variable, it may be true, turn to remainder variable. Either test and set lock. That process critical section lock to false and give that process to remainder section while true in the hardware solution of this problem. Coming to the critical section with semaphore. So semaphore are integer variable that are used to solve this critical section problem. Semaphore uses two atomic operation for process synchronization, that is wait and signal. So wait is a function, signal is a one function. These two are executed independently, if the process should be wait, then signal should be activate. Then signal should be activate after completion of signal, then the process, the remaining next process is going to be wait. Then its two are executing independently, then process executing the safely. Wait, the wait operation decrements the value of its argument as if it is positive. If S is a negative or 0, then no operation is performed. Wait of S, while S is less than or equal to 0, S is to be decremented. Then the signal operation is increments the value of its argument S, then signal of S variable, semaphore variable, then it should be incremented. Signal S plus plus, signal of S, then S plus plus. Let me give the concluding about the process synchronization in an operating system is the mechanism to coordinate the execution of multiple processes that access the shared resources, preventing data inconsistencies and ensuring the proper resources utilization. So either it may be a semaphore, either it may be a mutex, using the wait operation, signal operation, race condition or Peterson solution, whatever, to address these issues that arise when concurrent process attempt to modify the same data simultaneously, leading to race condition and potential errors. Okay students, I collected this information from the books Abraham Silversgrad, Peter B. Galvin, George Ganji, in Operating System Principles. It's the title of the book in Wiley Student Edition, 2010 8th edition. So another book is William Stallings, title of the book Operating System Internals and Design Principles, published at Patient Education, 6th edition, 2002. We have given the complete idea about the process synchronization and a detailed description of the critical section and then semaphores and then Peterson solution. We all are discussed in this video. Thank you students.
Like, share and subscribe. Hit the bell icon for more updates.